So in this recording, I'm going to talk about the concept of knowledge modeling in and then the context of generative AI. Now, the concept of knowledge modeling is no different than the concept of data modeling in the structured data world, where we model the structured data entities using some established data modeling techniques like dimensional modeling or Vault modeling. Now, as of today, there does not exist a established knowledge modeling pattern like what we have in the structure world in the form of Vault modeling or dimensional modeling. And the reason behind that is, and then this is what I feel, that we never thought that in the future there'll be language models which will need to understand the structure of the unstructured data and provide answers. We never thought of that. Right? It's so new. So as of today, as of now, humans were reading the documents and answering it. The relationships, the associations of the contextual content, the contextual chunks of the document, the associations of those contextual chunks within the document or across document was in our head, right? We were able to read the document and capture that relationships. We never thought of externalizing that information. But now, as we are maturing with this technology, with this generative AI technology, it is becoming very evident that if we are not able to provide granular context along with the granular associations to the language model, the response of the language model will not be 100% accurate or may not be expected at some for some questions. Right? Now, the thing is the knowledge modeling, it's easier said than done. Right? In the traditional structured data modeling, there are tools available and there are established patterns. We have people skilled to do such type of thing. The concept of knowledge modeling is very new. I don't know if people are even thinking about it or talking about it. But this is something that I feel is very much required if we want to have the RAG-based applications or the language models answer appropriately from the chunks or from the context it gets, right? Now, for creating the knowledge model and storing that knowledge model, I again feel that the traditional RAG approach, where we extract the chunks and store it in embedding databases, is not enough. It has limitation, because whenever there is deep nested relationships between the contextual chunks on the unstructured data, our traditional embedding stores, which are pretty much RDBMS in relational in nature, which stores the metadata as JSON, they fail to store the deep nested relationships. And that's where I think a graph database comes into picture. Graph databases like Neo4j can have both embeddings and the relationships as a graph, right? So it can both store the semantics of the chunk as well as the relationships of the chunks, right? So now we have the graph database to store it, right? We know that as I mentioned, like it's important to have knowledge modeling, but how do we do this knowledge modeling? Right? And then that's where I feel there is a void, there is lack of tool, and it is not as easier as we do data modeling, because it requires domain knowledge, understanding of the content, understanding of how the document is structured, understanding how the content within the document is structured, which is a context boundary, how one context is relating to another context within the document or across documents. That is not an easy task to do, right? But there are some semi-automated approach that we can apply, which is still in experimental stage, and then that is what I'm going to show it to you. And langchain is actually thinking about it, and this is a langchain wrapper that I'm going to talk about today, and then show you a demo of that langchain wrapper, which uses a language model to capture that relationship from the unstructured data and store that in Neo4j. So let's take a look at how it is doing it, right? So the wrapper name is, so I think it coded it here. So the wrapper name is LLM graph transformer. So what the LLM graph transformer does, once I instantiate the LLM graph transformer, I say convert to graph documents, and I provide the document chunks. Like these documents are nothing but, so I'm using the Wikipedia loader where I pass a concept, let's say. So in this example, you'll see that the concept is one term that I'm passing, which is the city where I was born, and it's my native. The name of the city is Agartala, which is in Tripura, in the state in India, right? It's a northeastern part of India. So here, when I give Wikipedia loader the term Agartala, it retrieves all the information about Agartala, returns that information, and then I pass that information into convert to graph document, which then extracts the different dimensions of the content along with the relationship, and we'll see what it does, right? So I just created a function which will just retrieve the content, the raw content, and then I pass the raw content to the knowledge modeling part, where I do a graph document equal to LLM transformer.converted to graph. This graph document is what I then add into Neo4j using the langchain wrapper, right? So I needed the Neo4j URI, username, password. So this is something I am using Aura, so it is easier for me. So this is the Aura instance. So right now it will be empty, right? So once I run it, let me run it, and then we'll see what it does, right? So let me do one more thing. Let me do a print of the documents as well for document in documents, print document. So we can see what document it prints, and then what we'll do is, let me do this also. I'm not sure if this will work, but we document in graph documents, print document. So here I'll say print graph document, right? So let's see how it does, right? So the main, first I am giving the concept as Agartala. I'm getting the documents, and the documents I'm passing. Let me run it, right? So when I run it, let's see what document it retrieves about Agartala. Yeah, it's taking some time. Pretty slow. Yeah. So it actually, okay, so how many chunks? 1, 2, 3, 4, 5, 6 chunks. Chunk size is 512 tokens, right? So it is Agartala is the capital and the largest city of the Indian state of Tripura, situated on the banks of Howrah, about 2 kilometers east of the border with Bangladesh and about 2,499 kilometers uh, from the national capital, New Delhi. According to 2022 AMC data, Agartala is the third most populous city after Guwahati and Imphal in Northeast India. So this is giving some um, information about Agartala. Then, since it is chunked, then it is a river. Howrah was named Haveli due to frequent invasion of the cookies and also to keep easy communication with British Bengali. The Maharaja Krishna Chandra Manikya started the process of shifting the capital from Old Haveli to New Haveli, present Agartala, right? So some of these chunks it extracted the from the uh, Wikipedia, and now it has started creating the nodes, right? So the node it has created, see the first node, okay, so this is something, some print I gave it into the langchain code itself. It is from there. This part has not come yet, where I'm trying to print the document of the graph documents. But let's look at this node relation. So the first node is in Agartala type city, Tripura type state, Howrah river is a node, right? And the relationships, it is also like it's a type river, right? Type place, group, right? So it now underneath the language model is extracting the relationship. So how does it do it? Let's look at that prompt also. So if I control click on this, I will go to the process response. So the process response, if you, okay, let me go back and show this to you. So the process response is being done on each document for document in documents, right? And what process response is doing is it is taking the raw, so the raw schema, right? What so raw schema equal to self.chain.invoke, and the input is the text, this text here, right? So what is this chain doing? So this is the chain, right? It is taking a prompt and it is using LCL, langchain expression language, right? And the prompt it is using is this, and this is interesting, right? So you see in the prompt, okay, the system prompt is knowledge graph instructions for GPT-4 overview. You are a top tier algorithm designed for extracting information in structured formats to build a knowledge graph. Try to capture as much information from the text as possible without sacrificing accuracy. Do not add any information that is not explicitly mentioned in the text. Nodes represent entities and concepts. The aim is to achieve simplicity and clarity in the knowledge graph, making it accessible for a vast audience. Labeling nodes, like so it is giving instructions to the language model, how to extract nodes, label the nodes, right? Consistency, ensure you use available types of node levels, ensure you use basic or elementary types of node levels, blah, 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 node IDs, relationships, right? If an entity such as John Doe is mentioned multiple times. So basically the system prompt is giving the instructions how to extract the nodes and the relationships. Um, then we have the human prompt. Make sure to answer in the correct form and do not include an explanation. Use the given format to extract information from the following input. This input is Agartala, right? And it also gives it some examples, right? Few short examples. So these are the examples, right? So Adam is a software engineer in Microsoft since 2009, and last year he got an award as the best talent. So this is that, if this is the text, then the head node is Adam, head type it's a person, relationship is work for, tail node is Microsoft, and the tail type it's company. So it is giving some examples also how to create the knowledge graph. And based on that, it is now capturing the nodes and the relationships for each. Yeah. So 1, 2, 3, 4, 5, 6, right? So we have 1, 2, 3, 4, 5, 6. For 6 chunk of text, it created 6 list of 6 nodes and relationships. Now it has pushed it to the graph database also. Let's take a look at the graph database now. So if you see, this is how it is created. Let's see what this node is. This node is Agartala, right? What is this node? Let's see. So this is New Delhi, right? what is the relation? Relation is distance, right? The value is this. So it has captured this. It is what other concepts did it capture? So it's say Guwahati, right? So this is Agartala, this is Guwahati, and let's see what is the relationship between the two it captured. It's saying it's a population. Okay, population rank. So it is saying that it is third after Guwahati and all, right? And then this is this I don't know what this brick party means, but what is the relationship? Uh, Ruled. Okay, so this may be a king which ruled Agartala, and then there are others. So this is what is this node? This is Bangladesh, right? So Agartala, Bangladesh is a neighboring country. So let's see what it is. Located near, which is excellent. Now connected, right? Okay. And what are others? So what is this node here? So this is Tripura. And what is, so Tripura and Agartala are also connected, right? So Tripura, okay, let's see what nodes are there for Tripura. So this is one node. So English, what is this English thing? Okay, official language. Tripura's official language is English. Well, English is one of the official language. The other language is Bengali and Kokborok. British Raj. Let's see what is this. Okay, this one is part of. It was part of the British Raj during the time when British ruled India. Okay, this probably is not a very good thing, sir. This is also not a very, okay, Bengali. So what is this? So what is this relationship with Tripura? This is saying that has majority population Bengali, right? So you can see now like how using a language model underneath and using this LLM graph transformer, the langchain's abstraction, given a chunk, it is extracting that relationships. Now the power of this, right? Now when I store this in Neo4j, I can not only store this, I can also, so if it's Agartala, let's say where it is Agartala, right? And if there is a like the text part of it, right? So I can store, I can also embed the description or the chunk description, embed them and store it in graph database, right? So when I have a question, I can first match the prompt with the embedding of the text, and whatever node comes in, I can then say, okay, give me all the other nodes which are connected to it along with the relationships. So now I can give a very, very rich context to the language model. It's not only the, the, the textual part of it, I'm also giving the relationship part of the chunks so that it can answer in a more distilled, more precise way, right? So that is all I wanted to demonstrate as part of this recording. So take a look at this LLM graph transformer. It is part of the experimental package. This is the experimental package of LangChain. And what I've seen is like, yeah, it will probably take some more time to mature. Consistency is still an issue, right? But this is probably one of the ways to semi-automate the knowledge modeling exercise that is very much required in creating RAG-based application. Thank you.